Hello everyone, we are pre-final year students of Weltech University. Our project is on speech emotion recognition using MLP classifier in machine learning. Myself A. Nitin Yadav, my teammates are A. Lohit and Ayush Kumar Mishra, and our project was supervised by Professor Dr. S. Sridevi ma'am. Now let's see about our agenda. In agenda, we have abstract, objective, introduction, design and methodologies, input and output design. Abstract. In this project, we define a SER system as a collection of methodologies that process and classifies the speech signal to detect the emotions in them. Here we attempt to detect the emotions in the recorded speech by analyzing the acoustic features of various audio files. Aim of our project. The main aim of our project is to identify the emotions in human speech and automatically classify them into happy, anger, disgust, fear, sadness, etc. We have provided the literature review. Design and methodologies. Here it is divided into 4 modules. Module 1 is all about creating the dataset. Module 2 is about training the dataset. Module 3 is about feature abstraction and module training. Module 4 is about MLP classification. These are the standards and policies. Implementation. In this we have architecture diagram. Architecture diagram is about it shows the basic architecture of our project. This is the data flow diagram. It shows the various steps to obtain the output. Testing. Here there are 3 types of testing: unit testing, integration testing and functional testing. This is the input and output screenshot, and this is a screenshot from our demo code compilation video. Conclusion. This was all about our project, and this project can be used for various applications, and it has many future enhancements. These are the provided web references and references we have provided here. This is the plagiarism report of our PPT, and we have provided the poster presentation. Now the code compilation part is explained by my teammate A. Lohit.
So coming to the coding part, our major domain is machine learning. So we are using Python code. So as our project is regarding speech emotion recognition, we are using Python code. So we are importing Python libraries. So we imported libraries like Panda, NumPy, Soundfile, Librosa, Matplot, Sklearn, Keras, etc. So coming to the packages that we installed, so Panda is for data manipulation and Num is for arrays. So we have various emotion recognitions going on in this project. So Globe is to get the directories to the code, and sound file is to read the sound file format. And coming to Librosa, it is a Python package for audio analysis, and Matplot, it is for plotting the spectrogram diagrams, and Sklearn, it is a matrix, it's for creating a matrix format to recognize the emotions. And as coming to the main coding part, we given the path of the data set that we are using. So as you can see here, this is the path of the various emotions of the different actors, like multiple actors with different emotions and different voices in each of the actor. So this is the path of the dataset and the emotions of the actors. So in the code, the Revidas data set path is been plotted in this code, and the commands like the list of the raiders directory is been given, and then it is been run. After that, the different emotions are been replaced with the file emotion columns, and then the after compiling, the number of counts in a graphical representation is being executed. So it states that the different emotions at different graphical plots, so number of counts and emotions. And then here we can see the commands like create wave plot. So it is for creating the wave plots for each emotion. Like here it is being given the file size like 10:3, so it differs from image to image. So we are using plt.title, so it plots the wave plots for the audio emotion. So here emotion is of fear. After giving the figure size and the data sampling rate, when it is been compiled, the data plots are been given, and the spectrogram for the each audio is been displayed with different graphical plots. So this is done for the different emotions with the code implemented in it, and then it is been tested. As you can see here, it is the emotion for angry. Create wave plot is nothing but it creates the particular wave plot for the emotion, and then it executes with the audio path and spectrogram. So here we can see the functions like def, noise, text, shift. So noise is for removing the noise from the audio files, and then text, it shows the accurate time, like accurate time of the entire model. And then shift, it states the range of the figures. And then pitch, it states the frequency levels of the audio with the function called display.wave show. It shows the data and sample rate of the audio pitches. This is done the same for entire emotions. And then coming to the final coding part, here it shows the result with, as we taken numpy, so it is completely of arrays, so it results in the ZCR, chroma shift, MFCC, like MEL. And then it will extract the features from the audio, and then it removes the noise from the data. And then stretch pitch has been used, like it shows the accurate time taken for the model to get the result. After this, the accuracy of the entire model is being calculated with the model.evaluate from the axis like x test and y test, like, and then the model is being trained and the accuracy is calculated. So here we are using a POCI of 50, so it runs from 1 to 50, like calculating from lower accuracy to higher accuracy. So it's starting with 1 by 50 with accuracy of 18, and then it is been continued till 50. This is the incrementation of accuracy from 0 to 100. So this is the accuracy of the model with 0.8478, it's around 84%. So this is the accuracy of the trained epoxy model of 50. So it will train from 1 to 50 to get the highest accuracy value, and then to figure all these accuracy and loss values, it shows we using plot epoxy's testless labels. So here finally we conclude that PLT function is used to title the confusion matrix and the predictor labels of the entire accuracy values that we got after compiling the code. Finally, the confusion matrix has been plotted, so it shows the predicted labels and the actual labels of the entire datasets and the emotion file. And finally we can see the predicted labels like all emotions together, values of precision, recall, F1 score, support, all values is been mentioned for each and every emotion. So final accuracy is mentioned. So this is how the speech emotion is been calculated from the audio files. So this is our project. Thank you.